Okay, year 13. I thought I would quickly go through those examples again for you, just so that you can reinforce what you uh, learned today in lessons. The same stuff, but you can now scroll through it at your leisure. You can stop me speaking. You can look at it again and get some ideas to what to do. Okay, so we're learning how to change the variable in an integrand so that we can integrate this thing. Okay, so here's an example. We want to integrate 5x and then in brackets x squared minus 3 all to the power of 7. Now, because it's all to the power of 7, it makes this quite a huge thing if you think about it. Nonetheless, we can, if we change the variable, integrate it. All right, so this is how you do it. Normally, you go and make what's inside these brackets, you say let that equal to u. And that's exactly our starting point. So we let u equal x squared minus 3, and we differentiate this with respect to x, and we get 2x. Cross multiply the dx over here, and we get that du is 2x dx. And this time you will notice a difference to what we have already been teaching you, that very often when we look at the connection between du and dx, it's just du multiplied by some number dx. But in this case, look what we've got. We've got an x that's crept in to this little differentiation. Okay, instead of it being 2 dx, we've now got 2x dx. Well, that looks like it could be a problem, but when you look at the original integral, you will see here, snuck in the corner, snuck in the front of the brackets, you will see a little x. Well, we can use that for that one. And that's what I've done here. I have taken this x here, and I've moved it down to there. Now, you can do that because all these things are being multiplied. The 5's multiplying the x, which is multiplying the brackets, and blah, blah. So you can just move the x anywhere you like. And I'm going to move it down there. Of course, I'm going to do what you already know, is that when I multiply the dx by 2, which I need to do because it's 2x dx, that I've got to divide by 2 at the same time to keep the whole thing the same value. But that 2 that I'm dividing by, that can go in front of the integral sign here as 1 over 2. And that this x can be written there, giving us this 2x dx. So in other words, that goes to du. So your integral then starts to look like this. Okay, you've got the 1 over 2 here. You've got your 5, you've got your brackets to the power 7, and now you've got your 2x dx. Well, that 2x dx is du. The brackets itself are u to the power 7. And one thing you should always try and do when you are about to integrate a thing like this is to make the integrand look as simple as possible. And this 5, which is multiplying everything, you can take in front of the integral sign there. And that's what I've done there. It's 5 over 2. And now I'm integrating u to the power 7 du. And now when I do that, I can quickly integrate, and it's going to be u to the power of 8 over 8. But don't forget, it's going to be multiplied by this 5 over 2. So your final answer, when I replace the u with my x squared minus 3, is going to be this 5 over 2 multiplied by x squared minus 3 in brackets raised to the power of 8, all divided by 8, and that 8 and this 2 will multiply to give 16. So your final answer for this integration is 5/16 brackets, x squared minus 3, close brackets, to the power of 8, plus the constant of integration. All right, now you could do this one for me in exactly the same way. Okay, now I'm going to do this one quickly because I did give it to you to do, and some of you did it very well indeed. So you're going to let this 5 plus x squared equal u, and when you differentiate that, you're going to get the following. Okay, let's see how it looks. Okay, when I differentiate this 5 plus x squared, you're going to get, again, the 5 will disappear, you're going to get 2x. So du will be 2x dx. And if I write that there, 2x dx, of course, what I've done is I've taken this x here and I've written it in front of the dx to get me this thing looking like 2x dx. I want it to look like this. But if I do that, I've multiplied it by 2, so I've got to divide by 2. And that division by 2 there can go in front of the integral sign, and we write 9 over 2, which now means that our integral now looks like this. This 5 plus x squared to the power of 11 must be u to the power of 11 du, because all of that 2x dx is that du there. And now we just integrate. So we integrate u to the power of 11 du is u to the power of 12 over 12 plus c. And of course, the u is 5 plus x squared to the power of 12. This 12 here multiplies the 2 to give 24. We could have made this fraction smaller by dividing top and bottom by 3, and we would have got 3 over 8. But really, it's okay like that. Okay. The most important thing is that you know how to do the integration. Okay, now let's move on to the next example, and I will have to zoom out and go to the next page, which is that one there, and zoom in again. Okay, how do I do this? There we go. That's nice. Okay, now this one is going to be quite tricky. Don't worry about all this stuff yet. I'll get to that. Just look at this integral. You're going to be asked to integrate x brackets 6x minus 1 all to the power 5 dx. And again, we concentrate on what's inside this brackets, 6x minus 1. And we let u equal that, which that means that du is going to come out as 6 dx. But now there is no x that connects the du with the x. In other words, we can replace this thing here inside the brackets with u and write u to the power of 5. But what about this x? There's no 6x dx like there was in the previous example. Okay, this is just, as we have already seen, it's just a pure number multiplying the dx. And so you've got a problem. Even if you replace, if you multiply the dx with the 6 and you divide by 6, as I've done here, you're still left with, well, what do I do with this x here? I can replace this with u, but what about this thing? Well, you've got to replace that x with u as well. But how? In other words, what you know is, we do know how u and x are connected, because that's the formula. So if we write x in terms of u by taking this minus 1 across there to plus 1 and dividing both sides by 6, we can write that this, an x by itself, is equal to u plus 1 over 6. And that's what we do. We replace this single x by itself by the formula for it in terms of u. And there it is. So you now can replace your integral with this thing here. This 1 over 6, don't forget I'm dividing by 6 because I'm multiplying that dx by 6. This now goes in front of the integral. There it is there. And my x can be replaced with that brackets there, u plus 1 over 6. And this brackets to the power 5 can be rewritten as u to the power 5. And of course, the 6 dx is du. And now we can tidy it up. Well, again, make the integrand as simple as possible before you start integrating. This 6, which is dividing this 6 here can be multiplied outside the integral sign to give us now 1 over 36. And look how now nice and simple this now looks. Well, this u to the power 5 now multiplies out the brackets to give us u to the power 6 plus u to the power 5. Let's have a look at that. There it is. There it is there. And we can now integrate it term by term. So this u to the power 6 is going to go to u to the power 7 over 7. And this u to the power 5 is going to go to u to the power 6 over 6 plus c. Now we just replace the u's with the 6x minus 1. And our final answer looks like this thing here. Okay, 1 over 36. Ah, yes, what I want to point out to you guys is the following, that you will notice that after I've done the integration, I've enclosed everything in these square brackets. That's because if I don't, it looks like this 1 over 36 is only multiplying this u to the power 7 over 7. But it's not. It's also multiplying that u to the power 6 over 6. So you must use these square brackets like that. My square brackets have become little squiggly things like that at the end, okay, when I've replaced the u with the 6x minus 1. And that's your final answer. All right, now, I'm going to ask you to do that one there, but I'm going to talk you through it quickly because I'm running out of recording time, strangely enough. And this is the way you would do this one, okay? You would say, again, you home in on the brackets. You say let u equal x plus 7. And so this time du by dx is equal to 1. So du is the same as dx. But this time we've got an x squared there. So we rewrite this thing in terms of x. X is equal to u minus 7. Well, if x is equal to this, x squared must be equal to all of this squared. And that's what you write there. You write u minus 7 all squared. This becomes u to the power 9, and that's du. This you multiply out the brackets, okay? And there it is there. And when you do that, you're left with this u to the power 9 outside those brackets. And so when you multiply it all in, you get u to the power of 11 minus 14u to the power 10 plus 49u to the power 9 du. Now you integrate all of those term by term, and you get u to the power 12 over 12 minus 14u to the power of 11 over 11 plus 49u to the power 10 over 10 plus c. And replace the u's now with the x plus 7, and there is your final answer there. Okay, now that funny little square thing you see there is because I put down the wrong answers when I did my answers late at night, and I was also so crammed for space that I had to make it really small. But I hope you can read it now. That is your final answer down the bottom. All right, now that's a little bit of a quickie on those two examples, but I hope they help you to understand what to do if you see those sorts of integrals where you've got to change the variable in order to be able to integrate things like that. You're changing the interval, changing the variable into a thing where you now can integrate. All right, thank you very much.